the modulus argument of a complex number. We are now ready to write a complex number in the modulus argument format. Right, so the first thing we're going to do is, if we look at the illustration below, I have represented z, which is 1 plus root 3I, and this is the coordinate. Let's call our point again P, and P has coordinate 1 plus square root 3. So I can see that if I call this again A, that the distance AP is square root 3 units and OA is 1 unit. I can work out what OP is. OP is the modulus of Z, and we know that the modulus of Z is the square root of A squared plus B squared, and it's going to be the square root of 1 squared plus root 3 squared. That gives me 1 plus 3, which is 4. The square root of 4 is 2. So the modulus of Z is 2. The next thing I'm going to do is calculate what is the argument of Z. And we know that the argument of Z, we call it theta, and to calculate it, it's going to be tan, or rather shift tan or arc tan B over A. Right, so in this case it's going to be arc tan of root 3 over 1 and if we enter this into our calculator, making sure our calculator is in the radian mode, we get pi over 3 or a third pi radians. So my argument is pi over 3, my modulus is 2. When we're writing our coordinates in this form, we can then extend our knowledge. Now we're going to have a look, and we're going to continue, and we're going to look at the different trig functions. So if I ask you what is sine of theta, so theta is pi over 3 radians. If I want to know what is sine of pi over 3, so sine of pi over 3, and we know that sine is opposite of a hypotenuse, it is root 3 over 2. If we cross multiply, we can see that 2 sine of pi over 3 equals to root 3. And I can also say that 2 cos pi over 3 equals to 1, because cos of pi over 3 is adjacent of a hypotenuse, and it is 1 over 2. So 2 cos of pi over 3 equals to 1. So I was given that Z equals to 1 plus root 3I. I can write it as Z equals to 2 cos pi over 3 plus 2I sine of pi over 3. We take out 2 as the highest common factor, reminding ourselves that 2 is the modulus of Z. So it's 2 into cos of pi over 3 plus I sine of pi over 3. This is the modulus argument form of the complex number Z equals to 1 plus root 3I. We're now going to generalize. So in general, we can say that Z equals to R into cos of theta plus I sine of theta. R is the modulus of Z, and remember we worked it out as A squared plus B squared. Theta is the argument of z. In example 2, we asked to express the complex number z equals to -1 minus I in the modulus argument form. Now, the first thing we're going to do is we're going to illustrate z on the Argand diagram. Right, so we're going to just do a rough sketch to see the position of z. So we got the, remember that our horizontal axis represents real numbers and our vertical axis represents the imaginary numbers of our Argand diagram. So we have the real value is -1 and the imaginary number is also -1. So this is an approximate position of z. You have -1, -1. And so the coordinate is -1, -1. If we draw the ray, we see that this is the angle theta, or the argument of z. The modulus argument form is z equals to r into cos of theta plus I sine of theta. Right. R is the modulus of z, and it is the square root of a squared plus b squared. So it's going to be the square root of -1 squared plus -1 squared, which gives me the square root of +1 plus +1, which is the square root of 2. Theta equals to the argument of z. Now, once again, we are measuring in the reverse direction, so theta is going to be negative. And I'm going to calculate it, so let me first find what's my reference angle. So my reference angle is going to be arctan of b over a, which is arctan of 1 over 1. And you enter this into your calculator, making sure your calculator is in radian mode. And this gives us pi over 4 radians. So therefore, theta is going to be minus pi plus pi over 4 radians, and that gives me minus 3 pi over 4 radians. Right, so we have all the information. We can now write it in the modulus argument form. We got z equals to the square root of 2 into cos of minus 3 pi over 4 plus I sine minus 3 pi over 4. In this example, our argument came up to a lovely number as minus 3/4 pi over 4. But remember, your argument or your angle can be a decimal because we're measuring in radians, and you are allowed to write it in decimal format, rounding off, say, to 3 decimal places. In the last example, we're given a complex number in the modulus argument form, and we are asked to write it in the form of z equals to a plus bi. So if I got z equals to 4 into cos of 2 over 3 pi plus I sine 2 over 3 pi, the best way to do it is to just to distribute 4 into the bracket and then use your calculator to calculate the values. But if you enter z as it's written there directly into your calculator, you can get it in the complex form a plus bi. But for you to do that, you have to first make sure that your calculator is in the complex mode. So if you press the mode button, If we press the mode button and we get to the complex mode, so we are now in complex mode, and you can see your calculator is in complex mode and it is in radian measure. And then all you do is you just enter this expression into your calculator, you press equals to, and you see that in the form a plus bi, the value is minus 2 plus 2 root 3 I.